Make the call to go ahead and skim the, I mean, you know, look, I'm raised up here. I need to take some of that down. We're already digging in here. We're going to go ahead and take a cross cut until we get smooth diameter here, and we're going to be doing the same thing on the other side. This thickness will be no less than it was at its narrowest point across there. So we're going to make this more uniform and hopefully get in here to where we have a little bit better weld surface around where the new weld is going to be. We got to open up the bore some. But we got that little edge right there. We want to minimize how much of a prep or an old weld area there. Alright, this is looking pretty good here. We'll probably let this cut finish down through the, and then we'll set up and do the bore. But this basically took most of the run out off of that face. You can see the little light bit of yellow still out there, but by the time it gets in here it'll be 100% clean. This breakaway area right there will be minimized. We still got some to come out of the bore, so that'll shrink down even more, maybe just a little bit of a grind, and that'll be clean enough prep to actually weld to. Okay, we're going to come in here and with our boring bar, and we're going to go ahead and skim our bore. Now this surface right here is our witness mark. We're going to leave that just like that. We're not going to take any more off this face. And it looks pretty good. We come into the welded area here, and you know, we're going to take a couple skims. We're going to see how sharp this edge actually becomes here when we get enough opened up out of there to have a nice clean bore. Like the bore was running slightly off from the OD because we're still dialed in out here, but we can see the height difference of the bore in relationship to that cut right there. In fact, it's actually starting to skip now, getting heavier on one side and lighter on the other side. So the original bore was never running true with that OD there. Alright, I just want to zoom into this section here to show you, and that is almost like a flame cut or a torch cut, and that's, you know, that's the remnants of where the outer roundness. So actually, they didn't even bore this to fit on the shaft. They just had a rough flame cut piece of material and welded it to the shaft and then machined it from there. Alright, so we're going to go ahead and put our inside mics in here. We're gonna find a comfortable diameter to go ahead and pour this to. We still have, we're about 300 or so on the shaft, and right now it looks like we're 135. We don't need to go extremely a lot larger on this piece, but we don't have to remove all that material on that OD because it's just open to the air and it's not really hurting anything. But we do want to get into some clean material here, so I'm going to go ahead and I think it wouldn't hurt to be out somewhere around 4,200 to 4,250, somewhere around in that ballpark area. I'm going ahead and take another 25 per side here until we take a look at it and see what it looks like. we just mic'd this up, and we got we're about 1.5 to 2 under 4 inches 200, and we're going to go ahead and we're going to leave it there. Now we have the boring bar in here, and our compound is set for 60 or 30 degree off of the angle for threading. And we're going to go ahead and we're going to use our bar right here, and we're going to go ahead and we're just going to skim that at 30 degree angle from the face here to clean up that area right there, just to get it kind of smooth and get rid of all the broken area there. And that's going to be our weld prep. There's just a couple areas right there and there, and we can hit those with a grinder, but it's pretty well going to be uniform. And that's the main thing, is we want uniformity, because when you're welding this around here, even though there's going to be weld draw and this and that, we want it to be minimized. And if everything is equal and you're not putting more weld on one side than you are on the other side, you tend to keep it. So the preheat, the post heat, uniformity on the weld all help keep things running true. And that's what this job is all about, because we're not going to change this. And we can take a skim on this face here, but minimum, but we can't touch this diameter right here. This has to run, the rest of our shaft and everything else has to run true to this, because this is a register for the adapting part. Alright, here's stretching the screen vertically, but alright, I got this indicator here on that same diameter we dialed in on the other side. And I've got this one up here with the reach over finger, and it's on this edge right here. Alright, now we're running, this, we'll just kind of, we'll set that about 0. And we're running about 32 thousandths right there. And up here at the top, we're starting out here about, we'll set that dial pretty close to 0. So we're running about 18, 19 here, and about 32 or so on that one there. Alright, so first off, what we're going to do is we're going to dial this in and out. And then we're going to go ahead and we'll tap it this way here to get our face back here again. And then we'll be ready to cut this outside. Alright, so let me jump in here. And first off, I'm going to go for tensioning on the... We'll loosen on the low side, tension on the high side. Alright, that's within about 1/2 thousandths there. Alright, now we need to go ahead and first off, I look between my jaws, and I actually see if there's any light between the jaws, so I know I can hit it in. Most of the time, if you're up against the jaw and you go to hit it here, it's going to bounce. Most of the time, you have to bring it out. Now, one thing that's nice about this reach over finger is its direction that way on loosen. So let's go ahead and we're going to take the high side here, and that's where we're going to tap. So this jaw looks like it's... That was about 12. And we're down to 14, maybe 15. Now remember, this surface right here ran about 4 or 5. And it held kind of like a double 0. Okay, so now we're going to go jaw to jaw, just like we did the other one. Okay, there's 0. There's -2. There's -2.5. And then there is plus 4. -2. -2. 0. -3. There's 2. -2. There's -2. -1, -3. Okay, so we're within 1/1000th there. Now we're coming back here. Okay, within 1/2 thousandths. -3, -1, -3, -2. Still within 1. We're going to call that running true. Alright, now we're going to go for this outside. Alright, this is the same thing. We're going to run with the negative insert here. And we're going to reach in. And we're going to knock off this weld here real close, and then we're going to come back and we're going to take a light skim across here, leaving a witness mark. And then just go ahead and give our whatever we have to clean up our prep area. Okay? Okay, here comes our first face cut. In fact, actually, we're going to have to come out here a little bit because the run out here, actually, we're going to have to reset our bit because the distance out here is farther than our travel here. Alright. This is about 30 thousandths right here off of the face here. We're making a new part, and we want that new part to be our standards, not the standards that it was manufactured from the beginning. What this boils down to is it's not going to be any thinner than the thinnest section to start with. All we're doing is taking the highs of the extra materials off that are run out. Alright, we just skimmed across this surface right here, and now we have a holiday in here, and we went ahead and we backed this all the way out. Now you can look in there and you can see the light in there, and I got my travel dial here set at 0, and I'm just going to come in until I lightly touch that diameter right there. Okay, that's 30 thousandths. Alright, now we're going to go ahead and we're just going to back this off slightly, so we got like 28 thousandths. Okay, now we're going to take a cut across there, and we're going to see how we finish off it there. With a slight little witness, we'll be doing good, and that's kind of what we like to have. Alright, this is our witness mark here, and we're not going to bother. That's only like 5 thousandths in that area right there, and we've come across here, and this is pretty sharp here with the exception of one little area. We're not going to try to clean that all up, but we are going to go ahead and give ourselves about similar to the other side as far as the weld prep and the angle that we put in on the other side. that's pretty close. You know, we're gonna hit that with a little grinder, and that'll be great. All right, let's go ahead and get this out. We're going to turn the jaws around. We're going to get the main shaft back in here, and we're going to be turning it for a press fit for this diameter in the location we want it. And then we're going to get it up, mounted on there, and we're going to get into the other room and start doing the wall prep. All right, on this first dialing here, we're still fat on this diameter here, so I'm not going to bother putting any aluminum shims in here. But I want to show you that my pocket scale can fit underneath the end of these jaws. That's how much bell mouth is actually in this old chuck here. All right, these two of them are a little bit worse than the others. All right, and we are running a little bit over 100 thousandths out. So I'm going to go ahead and crank that over through this diameter, and then we're going to go ahead and check our other two steady rest diameters that we had, and compare them all in this one setup here to go ahead and do the final turning. Hopefully with this choked up here a little bit more and using a positive insert there, we're not going to have a chatter problem, and we can turn what we need to turn in the middle here without having the steady rest. But now that we have the four jaw, we can perfectly make this run true. The other is perfectly running true in the center, and we're going to verify whether our steady rest areas are running true or not. So let's go ahead and crank this on over, and I'm going to start here with okay, we're within 1,000 there. Alright, let's tighten up the tailstock. It's tight. Alright, let's check within 1. Alright, let's check our next diameter. Which is there. Two thousandths. And our next one, about 1,500. All right, we're gonna go ahead and call that our preliminary, where we're gonna be running true, and we're gonna go ahead and skim it now. We know that this diameter is running true down here, and we're in the steady rest here, and we have confirmed that we are within at least 2 here and here. And we knew that we'd have somewhat of an idiosyncrasy because we were running in the 3-jaw, which we know our 3-jaw runs out a couple to 4 thousandths. Alright, we're getting ready to go for it. Start of our finish cuts here on this, and this is 4 inches 303 or so, and we got to get down to 4 inches 2. And we're just going to go ahead, because we need to start finding out if we're running true, and our tailstock is pretty well centered for this as well. We're going to give a couple skim cuts down here. We're going to plan out a section in the middle. It's going to be a press fit, slight relief on both sides here, just so we can get it in position. And we're going to press this thing on and press it into place and check our in dimensions with the press fit, so that we can locate this flange perfect on this shaft right here before it gets welded. So that's kind of our plan here. And we're at 450 RPMs, and we're feeding at about 25 thousandths per revolution. And that figures out to be somewhere around 530 surface feet a minute. Alright, this is a nice finish. It's coarse, but it's smooth, and there's no galling or anything else on it. So, you know, we can live with that. If we can get that to our finished dimension, we'd be real happy. Alright, 4 inches 265. 4 inches 267, and maybe a tenth or two. and 2 inches 66. I can't complain on that. This is open area. We just need to create a press fit in this area right in the center section here. So we're gonna go ahead and we're gonna bring it on down. We're actually gonna see if we can shoot for 4 inches 200 would be excellent. Our bore is about two thousandths underneath that. So and we're gonna practice with a couple cuts here. You were like 60 or so. That was about a 20 thousandths cut right there, and got us down to this point here. All right, we go ahead and we mic up the bore here. Get a good feel in here. And reading a couple under on the inside micrometer. Let's see what it reads with this one here. And exactly the same. About 198 or so. So we're gonna shoot for 200. 2 thousandths press on this diameter would be pretty good. It's not real tight, but it'd be enough to shift it back and forth so that when we weld it, it's tight to the bore and it's not gonna pull, it's not gonna cock, and we're gonna be able to control this on the shaft. All right, now our center section here where we're playing with. And we're getting like 230, 229 and a half, 230. All right, we're gonna shoot for it. We're gonna go ahead and we're gonna take 15 aside. Do or die. You can see that oil flow up on top of that bit, so it gets sucked into the heat. And the smoke is really the chip making contact with the oil back onto the shaft after it's been cut off. Finish. Okay. We're right on the money, and I touched off on that part. In fact, you saw me touch off on it, and if I would have went by my numbers on the dial, it probably would have cut it right to exact size, and it may not have had any press. Right now I know I have a 1.5 to 2 thousandths press right there, right where I need it. Alright, so now I'm going to go ahead and mark off, and I want to give like 5 thousandths undersize on both sides here so that I can come in from either direction there and press just that one little area side to side, so that we can set this thing up and be able to have free clearance all the way down, because I might heat and set that ring, and then maybe a little bit of press back and forth in the hydraulic press. If we don't have to pick it up, I don't want to have to pick it up. Alright, and our dimensions are right to there, right to there. That hook's going to set in there somewhere. Alright, so I'm going to go ahead and come in here with 5 thousandths, and then come in here with 5 thousandths. That's a good finish there also. came back in right there. So that was the 5 there. Now we're taking the 5 here. Now I'm not sure what it looks like on camera, but to me, naked eye, when I stare at that and then stare at that, it don't look like that is going to fit in that. But it's just an optical illusion because I've measured that and it's only 2,000 smaller than that in the middle. But each end, this side here or this side here, is under that diameter. Well, the older you get, the heavier this stuff gets. But I'm not, you know, you get a little smarter. And actually, I kind of kick myself now because I wish I'd smartened up just a little bit earlier. So, not that I'm worn out by any means, but it is. It's getting a little slower, and everything's just not as beefy as it used to be. Alright, now we're going to get this and that flange in the hydraulic press. I guess we're getting this over there soon. Alright, this is going to be a little bit high to be lifting up here, and we got this flange, and we're going to be shoving that down in there, and this is a little bit high for me. So right now, I'm going to go ahead, pull that pin out. Alright. Slap that into there. Alright, and alright, now it's a little bit more manageable, I think, and we'll be able to get this in here, and we may need a little bit of room there, but for right now, I'm hoping to have just a little bit of a block here. Let's see, what do we got here? Down to the top there, like 26. That's like 20. Okay, we're not even gonna hit that. We'll be free. Okay, we're going to roll this into there and guide it, and then it should hit this, somewhat go into it. Here we go. Okay, now we're going to go ahead and press that until we get our 19 and 15/16 measurement from here to here. I'm going to take a measurement and I'm going to put a line because I only want to do this once. And probably going to have the crane come in and help me lift this thing out of here, or crank this table down to where it starts floating up and I can get it up out of that hole. But this is totally awesome that I got it in there in my fits and measurements. And a little taper on that thing, but it sure did make it through there. Alright, we have exactly 1 inch. This is 17 and 9/375. 17 and 15/16 right there. Exactly 1 inch. Alright. So, exactly 1 inch. I'm going to go get a 1x2 block I have.